Hi, my name is Anika, and I would like to introduce to you our bounty hunter robot swarm. Our robot swarm will identify, subdue, capture, and detain a human that is wanted. We created this team of robots to give customers direct or indirect another option to get a particular job done. We chose this in an effort to make a difference in time and efficiency. The following is a list of our customers, either direct or indirect. Our design requirements are as listed. These are all based on durability, some accuracy, others precision, team and operator communication, and last but not least, stealth and longevity. We will now introduce the individual robots of the team. They will include an identifying recon, subduing taser, a restrainer, as well as a transporter.
Hi, my name is Efrain Robles, and I worked on Lanky, the aerial recon drone. Lanky is a recon aerial drone modeled after a helicopter equipped with a three-bladed top rotor for efficiency, speed, and noise reduction while utilizing a tail rotor to prevent counterspin. At 16 inches at the longest, 12 inches at the widest, and 13.5 inches at the tallest, Lanky is a great outdoor surveillance as well as indoor reconnaissance tool due to its small form factor. Lanky is equipped with stereo cameras right here in the front to identify 3D objects and communicate video feedback to the operator. This way, the operator always knows what is going on visually and can help make important decisions for their operation. Lanky is also equipped right here in the front on the top with an IR thermal sensor in order to differentiate between objects and potential targets. This is my activity chart for Lanky. It is going to start with Lanky preparing for lift by setting its servo to 90 degrees to give it that forward and backwards movement. It is then going to make a decision if it is safe to lift off based off if there are objects around it or not. If there is an object in front of it, it is going to set the servo to reverse and it'll fly backwards to get away from it. But if not, it's just going to go ahead and do a standard lift and lift off. It is constantly going to be checking for objects around it to make sure it is safe and get away from them if they're not. If not, it's just going to continue to move forward. As it moves forward, it is constantly going to be checking the temperature of objects in front of it to see if there's an object in that human temperature range. If not, it will not mark the object as a target and it'll just continue searching. If so, it will mark the object as a target and it'll go ahead and communicate that to the central hub and to the robots of the swarm. Here is my circuit for Lanky to showcase exactly how everything is going to work together. I have my ultrasonic sensor here that is going to tell my Arduino board if there is an object within 6 inches or not, and if that's going to tell us whether or not to turn on these motors and it's safe to fly. Here is the servo motor, which is connected to the main rotor, which is going to deal with tilt. Right now it's in the 135-degree position for forward movement. Here is my main rotor, and here is my tail rotor. And this is controlled by this L293D chip, which is going to tell each motor whether to turn on or off, and is also going to control the speed. We control the speed with through these pins, the enable 3 and 4 and the enable 1 and 2, which are connected to the PWM pins on the Arduino board, and that gives us the ability to control their speed. Here is my Arduino code for my project. Here, before the setup, I did label all of my variables so that it's easier to read in my code, as well as put comments to organize everything. I did an interesting thing of in my setup setting one of the servo motors to 90 degrees outright, and that is to create a baseline. It gives it the ability to move forward and reverse in the code. In my loop, I have my throttle set to an analog so that it can have variable output, as well as the yaw, which is going to choose the direction that the actual drone is facing. In the temperature area, I put that it was going to mark a target if the temperature was between 35 degrees Celsius and 41 degrees Celsius, which is human temperature range, about 95 degrees Fahrenheit to 101 or 100 degrees Fahrenheit. Here in the serial monitor, this is going to be the information that is being transmitted to the hub as well as to the other drones. So we have the temperature, which is the Celsius. You have the target being marked, and then you have the distance that it was from. the drone.
I'd like to introduce to you Super Bowl. My robot was created to be the subduer of the team. It is equipped with wheels and propellers for both ground and air capabilities when needed. This design is most optimal, seeing that the wheels give it a 360-degree rotation as well as its propellers. Super Bowl's best features are mimicked from that of a taser, which each arm is designed to give off at least 110 volts. Equipped with a dual camera system with infrared capabilities, as well as a temperature recognition. Altogether, this robot is small in size, but mighty in force. As you can see on the image, although SuperVolt is small, it is equipped for almost anything. The circuit displays the ultrasonic distance sensor, which is used to help locate the target. 2 servo motors that represent its arms, which are set to turn on within an inch of its target. As you can see, the infrared sensor is shown, as well as the temperature sensor, which is programmed to confirm if the target is within 35 to 41 degrees Celsius. Lastly, we have our battery, which says 9 volt, but represents at least 110, which charges the 2 LEDs, 1 LED per servo motor or per arm. These both simulate what a taser would be in each arm. Here's the Arduino code. This is listed from start to finish. The robot software is best represented in the Arduino flowchart, which, if you can see here, starts with preparing to subdue its target. The first decision is the potential target within 1 inch? If the answer is no, then it's required to move a little bit closer to its proposed target. If the answer is yes, it will immediately read the temperature from its sensor. If that temperature reads between 35 to 41 degrees Celsius, or as listed, 95 to 101 degrees Fahrenheit, then the target is immediately marked as verified, which will ignite those lasers or those tasers, which, as represented, is going to be the LEDs. If the target is not, or if the temperature is not within that range, the target will be marked as invalid, thus prompting the LED lights or the taser to continue to stay off and start from the beginning. And that is my robot.
Hello everyone, my name is Claire Miller and I will be introducing my robot Legolas. His job of the swarm is to restrain an incapacitated target. Here are the components of his shell. He has 8 jointed legs attached to the body as ball and socket that allow for flexible movement and to grip a target. The 8 eyes that you see are his LEDs that are connected to a temperature sensor and will stay on or blink depending on the temperature reading. His body dimensions are 8 inches by 16 inches by 3 inches. For his components, we have the Arduino Uno, a breadboard, and a battery. Also a distance sensor, which tells Legolas how far he is from a target. The temperature sensor detects the temperature of the target. He has 2 motors for movement, and finally 8 red LED indicators with 8 resistors of 215 ohms each. Legolas's key feature as a restraint robot is to reach given coordinates and lock his jointed legs around an incapacitated target's limbs. He is mobile and receives instructions from other robots and or the central hub. The temperature sensor will only release if it senses the target's body temperature has fallen above or below a normal temperature range or is given the command from the other robots or the central hub. Here is his activity chart. Legolas receives a signal from Supervolt that the target is incapacitated and is then given coordinates from Lanky to the location of the target. He will move towards those coordinates until the distance sensor shows he is in range. He will lock his jointed legs around the target's limbs with the temperature sensor flush against the target's limbs. Once the target is restrained, Legolas will signal to Peeves that the target is ready for pickup. The legs will stay locked around the target until the temperature sensor reads a dangerous temperature or he is instructed to release the target. Finally, here is the circuit code. We have the red LED eyes always on with the condition that the target's body temperature is above 35 degrees Celsius and below 39 degrees Celsius. Outside of this range, all of the LEDs will blink to signify the target may be in distress. The distance sensor is set to have Legolas move using his motors to the target until he is within a certain range.
My name's Kate, and this is the robot I designed, Peeves. Peeves has a full body length of 36 inches and a total width of 24 inches. It will be padded in foam to protect itself against small falls and if it tips over. The robot will move around by the wheels attached to its body. A cage-like container is attached to the robot that will encase the wanted individual, letting the robot be able to move them to the client's desired location. The robot will have an arm to move around, but the main purpose is to move around the cage, but the main purpose is to latch onto the container to connect it to the machine. The robot will be able to communicate with the other robots in the swarm by using a wireless transceiver. The robot will have 3 sensors attached: a thermal sensor, a distance sensor, and an IR sensor. The robot will have 2 actuators, such as the wheels and the twisting and connecting arms. This is the circuit I made to complete the tasks my robots can do. The components I used in the circuit are a distance sensor, which will help navigate between obstacles such as objects, furniture, and walls. 3 micro servos, 1 black, 2 blue. The black servos are for the rotation in the arm, and blue to rotate the parts like the wheels when they twist and turn. I have a IR sensor and a temperature sensor. Both sensors will help when identifying between objects and the wanted individual, depending on the amount of heat they give off. This is the declared variable and setup part of my code that I use for my circuit board. And this is the loop part of the code that I use for my circuit board. This is the activity diagram for Peeves, which gives you insight on its behavior and process when completing its actions.
Here is the collective behavior for our swarm. It is going to start with Lanky, which is our aerial recon drone. It is going to do surveillance of an area or recon of a building looking for potential targets. Once it finds a potential target, it is going to read the temperature, find if it's in the human temperature range, and then it's going to mark it. Once it's been marked as a target, those coordinates are going to be sent over to the central hub as well as to the rest of the swarm, and that is what is going to activate Supervolt to go ahead and start moving closer to that target. Once Supervolt gets into that 1-inch range of the target, it is going to verify it by checking the temperature with its sensors. If it cannot verify that that target is in that human temperature range, it is going to mark it as an invalid and it's not going to activate its tasers. In the event that it is a target and it is within that human temperature range, it is going to mark the target as verified, and then from there it will activate its tasers and incapacitate that target. Once the target has been incapacitated, it is going to send that information over to the hub and the rest of the swarm, and that is what is going to activate Legolas. Now that Legolas has been activated, Legolas is going to go ahead and advance towards the target's location. If it's within range of that target, it is going to close its legs around the target and restrain that target. Once it restrains the target, it's going to read the temperature again for medical purposes, just in case the target goes into shock or something happens. That gives the operators the ability to tell Legolas, hey, let go of the target, it's a medical emergency, or to keep them binded and wait for Peeves to go ahead and show up. Once the target has been restrained, Legolas is going to go ahead and send the signal to Peeves and the hub that the target has been restrained, and that is going to activate Peeves. Peeves is going to come out, start advancing towards the target. Once it is within that range, it is going to open its cage door, unattach the arm from the cage, grab the target, put them into the cage, and then drop them off at a location.
Our robots will benefit the local populace as well as politicians attempting to lower crime in their respective areas. Our robots will be completely equipped and prepared for customers' requests and will do said tasks as stealthily, quickly, and efficiently as possible. With these robots, locating and capturing wanted individuals will be made easier and more efficient than ever.